Hello everyone. Now we'll be talking about correlation. We have already studied about scatter plots in our previous video, where we learned how we can show basically the association between two variables, right? So, or we use scatter plots to basically show correlation between two variables. So let's study another method, how to find out the actual correlation, rather just describing the correlation based on form, direction, and strength that we did using scatter plot, right? So what are the formulas that can help us to find out the numerical value of correlation, to which will help us to make better decisions, right? So let's study about it. So in this video, we'll cover scatter diagram again in brief and Carl Pearson coefficient of correlation. We have other measures too that we'll be talking about in our upcoming videos. So now these terms are used, and together most of the time, like correlation versus regression. So what is the core difference? Let's see. So correlation is a statistical measure which determines correlationship or association between two variables. So it just tell us what is the strength of relationship, direction and type of relationship. But regression analysis, right, it helps us to describe the relationship, like what kind of relationship they have. And it also gives us an equation to you know which shows what kind of relationship is there. Okay, so we have different type of regression that we'll be talking about in later videos. So I'm repeating it again, like correlation is not necessary that it is causation as well. So what is causation? Causation, as we can see, one variable causes other, right? But yes, there's a difference between these two, as we can see. So a correlation between variables, however, doesn't automatically mean that the change in one variable is the cause of the change in the values of other. So it is not necessary if two variables are correlated, they are having cause and effect relationship. They may or may not have. Causation, on the other hand, represents that one event, like change in the value of y, right, is the result of occurrence of change in value of x. So that is causation, right? So this is the difference between causation and correlation. Like we have one example, like sleeping, one person says, sleeping with my shoes always gives me a headache, right? So his friend says, oh, weren't you drunk last night? So sleeping with my shoes, that the first person observed that whenever he sleeps with his shoes on, right, um, he has a headache, right? But the cause is something else. Like he was wearing shoes, he slept wearing shoes as well, and the cause of headache, right? So there's another example which clearly depicts that correlation not necessary is causation, right? So there are still, if it is not clear, I have a very clear example to make it more clear. So suppose you're using an app to purchase goods. So if you see there are too many steps in purchasing or making payment, which will lead to a cart abandonment, right? And also, if there are too many steps in purchasing, what will happen? You will uninstall the app, right? So, and when that organization, the app organization is basically um, finding out the correlation, like what is the correlation between incidences of cart abandonment and uninstalling the app. They will definitely see a relationship, but the root cause is something else. So so that is why we can see the correlation between these two variables, but the root cause is something else, which is too many steps in purchasing, right? So I hope now it clears the doubt that how correlation is different from causation. Okay. So what are various advantages and disadvantages of using a correlation? Advantages can be, it can show definitely the strength of relationship between two variables, and we can easily study the behavior, like how two variables are related, when if one variable is changing, other variable is changing or not, and to gain quantitative data which can easily be analyzed, to make various decisions, right? Business decisions as well. So disadvantages, it cannot show cause and effect. Okay, and like there are two variables we are studying, but it is not always a case that what is your main variable, what is other variable. So no control on third variable that might affect the correlation, like we discussed in the earlier example. So this is just another example. So if suppose we can see, when we are seeing these two trends, we can see they are they are following the same trend. US spending on science, space and technology, and suicides by handing, strangulation and suffocation. They are following the same trend. If we will plot a correlation between them, it will be a perfect correlation. But we can clearly see that US spending on science, etc., is not at all a reason of suicide, right? So how to measure correlation? We have already discussed about scatter plot, where we plotted, the points on a chart. Okay, so which basically displayed the strength, direction, and form of relationship. Strength can be a strong relationship, moderate relationship, weak or no relationship at all. Direction can be positive and negative, and form can be linear or non-linear. Okay, so now type of correlation, when we talk about, definitely all correlation have two properties, strength and direction. The strength of correlation is determined by its numerical value that will get using different measures, and direction is determined whether the correlation coefficient sign is positive or negative. Okay, so positive, negative, positive correlation means if both variables, suppose we have two variables x and y, if x is increasing, y is also increasing. If x is decreasing, y is also decreasing, right? So both variables are moving in same direction, so that shows a positive correlation, right? And negative correlation is basically if x variable is increasing, y is decreasing, and if x is decreasing, y is increasing. So they basically opposite direction. They follow, like they move in opposite direction. Okay, so that's it about positive and negative. So let's see a very simple example to understand it, scatter plots and correlation coefficient. So we can see, like there's a sunny day and temperature is rising over time, and we are plotting sales of ice cream associated with different temperature values, right? So if we like in first column, you can see temperature in degrees Celsius, and ice cream sales are shown in second column, right? So when we plot this diagram, suppose we are taking temperature on our x-axis as a major variable, and we have sales. Like suppose when temperature is 14.2, right? Suppose let's start with the minimum temperature range. Suppose temperature range is around 12, then our ice cream sales are 215, right? So we can see 11.9 and 215. So we can easily plot the points, right? And now you can see, as we learned in our last video or scatter plot. So this type, this is showing a positive trend. Suppose if x values are increasing, y value, that is sales, are also increasing. So definitely there's a positive relationship. Okay, and kind of linear relationship, right? And what else we need to see? Strength. So all the points are basically, cluster on the central line. So the strength of relationship is strong. Okay, so as we can see in scatter plot, we are able to make out the type of correlationship, but we don't know exact value of correlation, right? So for that purpose, we find out correlation coefficient, which is represented by small letter r. Okay, so in this graph we have already discussed, we can easily see that warmer weather and higher sales go together. The relationship is good but not perfect. Okay, so this is a table, gives heights and weight of 10 friends. Okay, so you can practice this question to first plot a scatter plot, and you can see, now you tell me this is a positive, negative, or no relationship at all. So we can see, if when x values are increasing, y values are decreasing, so it shows a negative trend, right? And we can see the relationship is not linear, so it is non-linear relationship, right? Got it? Yeah. So that is how we can make out the read the scatter plot after plotting it. So as I told you, another way is to find out the Carl Pearson correlation coefficient, which is represented by small letter r. Okay. So there are certain, conditions or assumptions you can say to find out correlation coefficient. So here we have two variables, suppose x and y, right? Um, X and y. So what we assume that both these variables should follow a normal distribution curve, right? The values of x and y. Other assumptions include linearity, like if x is increasing, y is increasing in the linear way, right? There's a linear trend, okay? And another one is homoscedasticity. So linearity assumes a straight line relationship between each of two variables, and homoscedasticity assumes that data is equally distributed about the regression line. Now, what is the regression line? Suppose this is scatter plot. We try to plot a trend line or best fit line. Okay, how we plot this line? If we are just uh, drawing this line casually, we can have one generic rule of thumb that suppose there are certain points. So if you're drawing a line, it should basically have equal number of points above and below it. Okay, and so that is our assumption as well. It should be equally distributed above regression line. So the exact equation of this line, will learn how to find out the equation in regression analysis, right? So correlation coefficient is a statistical measure that calculates the strength of relationship between relative movements of two variables, and the value of r ranges between -1 to +1. um, if you're getting any value greater than 1 or less than -1, so definitely there is some error in your calculation, right? So let's learn. So as I've already told you, if we also call it Pearson correlation coefficient, Carl Pearson correlation coefficient. Okay, so this I've already told you, positive and negative correlation. So now here is the formula for calculating R. We can use, both formulas are similar, but you can see which you can use any of the formula which you feel, simple to use as per your convenience. Mostly we use this formula because calculations are a little easier. You have to just multiply and xy values and do the summation, and then we average we are already calculating, and we have to calculate square of x and y values, and we can use this formula as well. Let's we'll be solving a sum using this formula, so that you learn how to solve the sum as well, okay, for your exams. So now we can see three figures with different r values. So this r value shows there's a positive 0.4 value. So there's a kind of linear relationship and positive trend. R equal to 0, we see a flat line. So there is no correlation, sparsely, distributed points, and negative shows there's a negative relationship. So this is basically a measure, right? This this basically this chart shows you the values of correlation coefficient, which shows strength and direction of correlation. So when when our value of r, this is for r values. If our r values are near 0, so we can say it is kind of weak correlation between two variables, and between 0 to minus values and positive 0.5 values, we call it kind of weak. And if r values greater than 0.5 plus minus 0.5, there's a strong correlation, right? So negative sign before r value shows there's a negative relationship. Okay, so why you need to remember this chart? Because suppose your value is minus 0.8. So after calculating the value, you have to tell as well what this value represents, right? So minus sign shows there's a negative correlation, negative relationship, and the values 0.8 lies between 0.5 and minus 1. So there's kind of strong negative correlation between two variables, right? So here's an example where you will be using this formula, this one. Okay, so you can see now two variables are given, x and y, and you have to find out the correlation coefficient. So what we require for this formula, see, for every question in business statistics, first you have to see what formula you are applying and do your calculation accordingly. Suppose here you need x minus x bar, y minus y bar, and then a summation of square of all difference values. Okay, so what we have to do, first of all, we need to calculate x bar, right? So these are x values, these are y values. So x bar is basically your average. So x bar would be sigma x all the and divide by number of observations x. And similarly, y bar you will calculate summation of all y values divided by number of observation. So next step is definitely what we need in this formula, x minus x bar, multiplication of x minus x bar, y minus y bar. So we have multiplied, we have calculated x minus x bar, right? How we'll calculate? This is the x value, 12 minus x bar, 12 minus 5, 7. So we have kept it here. So likewise, we'll calculate all the values where our x bar value is 5, right? We will minus all values from x values, right? And similarly for y. So x minus x bar square will calculate, y minus y bar squares will calculate, and multiplication of x minus x bar, y minus y bar. So you can see we need summation of all these values. So summation of x minus x bar square is 96, summation of y minus y bar square is 26, and summation of multiplication of this is minus 6. So what we have to do, we have to just put in the values in our formula. So this, what is the value here? 6 minus 6. So we'll put minus 6 and divided by square root of multiplication of summation of these two values. So we'll just put in the values and our value will come. So what does this represent now? Minus sign represent negative correlation, right? And now let's see where this value fit here. It will be somewhere here, 0.12, right? So this shows a weak negative correlation. I hope now you are clear how to, understand how to calculate the value of R and how to find out the decision, how to, explain your answer. Okay, so there's another example which I'll try to explain using Excel sheet as well. So you are also aware how to find out correlation using Excel. So just a second. Now, suppose I have this question, the same question. So here are your x values, here are your y values. So first thing is to calculate x bar. So this is average of all x values. Similarly for y bar, you need average of all y values. So what we need in the formula? So in the similar fashion like we calculated for earlier, sir, x minus x bar, right? This is x minus x bar, then y minus y bar. Then we need square of x minus x bar ka square, y minus y bar square, and multiplication of x minus x bar into y minus y bar. So this is the multiplication. So summation of multiplication is minus 92. Okay, so and then summation of x minus x bar square is 120. Okay, and y minus y bar is basically y minus y bar is 184. So when we'll put the formula, see, this is the value of basically this multiplied by this, and this is square root of this value, which you can use using the calculate using square root function. And this is basically all the values we put in the formula, that is r is equal to minus 92 divided by 148, right? So we get the correlation value as minus 0.619. So you can say it is kind of moderate correlation, but it is negative, right? So now, definitely when you have to calculate manually, you have to do a lot of things, but you can use this function, right, for finding out correlation in Excel. Okay, so when you will choose this function, you can directly see it will ask for two arrays for which you need to find out correlation. So once you select this function, you choose your first array, right? This is your first array, and then your y values, right? And then close the bracket and press enter. Now you can see our values are same. So this is very simple way, very simple function where you can use correl function to find out correlation in Excel sheet. Okay, so there's some other examples you can try. There's some Sophia, who is a very good student, but at times she doesn't get enough sleep. So she hypothesizes that when she get more sleep, she does better on tests. To test this, she tracked how she did on a number of tests based off how many hours of sleep she got on the night previous. And she input the following data set like hours of sleep and the test score. So she wanted to see is there any correlationship, right? Any relationship between number of hours she's sleeping and the test scores that she's scoring, right? So she just used the correl and find out this relationship. Yeah, and she could see there's a positive value. So, she could relate that there's a positive correlation and moderate too, right? Right? So that is how she used Excel to calculate this. So application of correlations are too many, especially when you need to see what kind of correlationship exists between two different variables. Suppose the amount you are spending on advertisements and sales of your product, right? And like the money you are spending and returns you are getting everywhere, like you are investing in your shares, and what is the correlation between the share performance and government policies. So all everywhere correlation is used. In an investing banking as well, they see what is the correlation between various factors which are impacting share market. Okay, and they can take decisions to diversify their portfolio, right? Demand, this is the first law that we study in economics, right? The relationship between demand and supply. So yes, that also shows a correlation between price and demand, right? Like this. So that's all. Thank you so much. So in next video we'll be talking about Spearman Renko relationship. Okay, so keep watching. Thank you.